Hello students, my name is Dr. Gajendra Purohit. I upload videos for engineering, mathematics and B.Sc on my channel. If you are preparing for any competitive exam where higher mathematics is asked, our channel is very helpful for you. Today I will explain about the next topic of total differential equation, and it is the next method known as auxiliary equation method. Before this I uploaded a video on the inspection method and I tried to explain it. I explained how can we solve total differential equations using inspection method. Now we will discuss the next method, the auxiliary equation method, how we solve equations using it. You will get questions in exam where you will need to identify which method will be applicable, but if you study all four methods, then things will start making sense to you. Let's start. How to solve this? If we have any total differential equation of this type, then first of all we need to check. Before this I uploaded one video. In that video I explained that the integrability condition needs to be applied here. What is that condition? Let me explain you that if we have any equation of this type, P dx plus Q dy plus R dz is equal to 0. In this equation this is P, Q and this is R. We write X, Y and Z here. Then what is the condition we have? Pay attention. It will be P into. We will differentiate this with respect to Z, right? Then minus this will be del R by del Y. Plus this will be Q. Its value will be differentiation of R with respect to X. Del R upon del X and minus del P by del Z, and then it will be. Plus here the value will be R multiplied by. What we will do? First it will be R into, and it will be del P by del Y minus, then here it will be del Q by del X. So this value should be 0. If this value is 0, then this becomes integrable. If you remember this formula, then next method will apply right from here. How will we do it? You need to pay attention. This 1 and this value that we get here, what we will do? We will write this as dx upon del Q by del Z minus del R by del Y. Clear? And then on this side equal to what we will get? dy upon, in denominator this will be del R by del X minus del P upon del Z is equal to, we will get dz upon del P by del Y minus del Q by del X. In this way we will get this value. Now we will solve this here using the same concept as the Lagrange method for linear partial differential equations. We will have two solutions, u and v, and then the values of u and v which we will get, we will put in this equation. Then we will differentiate this expression, and after differentiating the equation it will be compared to the given equation. Clear? At this point, after comparing, we will get the values of a and b. We will put those values of a and b here. Then we will integrate it. After that, we will put the values of u and v. We will obtain the answer. It might seem tricky. And now let me show you how to solve this question. We have this equation given here. We need to check if this can be solved using the inspection method. But we can observe that it can't be solved using inspection method, right? It is not possible. Now I told you that first we take the integrability condition and we use it here. But I want to tell you that we can apply it in this way also, because whenever we have any question, that condition certainly applies here. Still, if you have any doubts and if you want to check, you can check it. It is the same as what I explained. What we get here, first it is dx upon. I'm telling you the way to remember the formula. We will put this here, del Q by del Z minus del R by del Y, right? It's equal to dy upon, what will it be here? Pay attention, this will be del R by del X minus, you see, this is del P by del Z, right? It's equal to dz upon what we will get in denominator. This P will come here. So del P by del Y minus del Q by del X. This will be our equation. As I explained you that we need to solve it and then find the solution, right? The value of P is this. Q is minus Z and R is 2Y. We'll put all these here. This will be dx upon differentiate Q with respect to Z. It will be minus 1. If we differentiate R with respect to Y, we get 2. So it will become minus 2. dy upon differentiate R with respect to X, it will be 0. R is 2Y, its partial derivative will be 0. Now P with respect to Z. This will become minus 3xz square, right? And then it will be is equal to dz. If we differentiate P with respect to Y, we get 0. If we differentiate Q with respect to X, this will also become 0, right? Whenever we have this type of equation, we equate it equal to lambda. First 0 will be cross multiplied, so we will get dz is equal to 0 and Z will become C1. We will get the value of Z as C1. Now let's look at these two. So we will get dx divided by minus 3 is equal to dy upon minus 3x. We'll put the value of z as c1 here, then we'll get c1 square. Now 3 and 3 will get cancelled. Cross multiply it. This is dx. Take this c1 square to this side is equal to dy. Now we will do its integration here. We will get c1 square. X square by 2 and is equal to, we will get y on this side. Plus here, c2. Now substitute the value of c1 again. This will be z square. X square by 2 minus y equals to c2. We got c2 here and this is c1 here. Now we know whenever we get an equation of this type, then what do? We have c1 and c2 here. Let me tell you, we take the value of c1 equal to u and the value of c2 is equal to v. Therefore, if you see the value of u that we are getting here, it is z and the value of v is, if I will multiply with 2, it will become x square z square minus 2y, right? We put it into constant. This will be the value of v and this will be u, right? So now what we will do? A du plus b dv is equal to 0. We put this here, right? What do we get here? We get u. We will differentiate this. We will find du, it will be equal to dz. Then what we will obtain when we will put it here? We will get a dz. Plus we will differentiate this here, right? We will do dv. So what will be the value of dv? Here their derivative will be by u into v. So if I find dv, then dv will be equal to differentiate x square. This will be 2x z square and dx. Plus differentiation of z square will be 2x square z dz. And then its value will be 2 dy, right? Now we will substitute this value here. We will get b into, pay attention, we put value of dv. So this will be 2x z square and dx plus, and it will be 2x square z dz, right? This will be minus 2 dy. At this point we will get this value. Now we will compare this value with it. I will systematically write down the coefficients first. I will write dx first and then we will get here 2b x z square and here we have dx. Now what will we do? We take the next coefficient of dy. So the coefficient of dy is minus 2b dy because b is multiplied by dy. Then it will become 2b dy. Now the coefficient of dz is here as well. So here we have dz common, so taking that out we will get a. Then plus the next term will be 2b x square z multiplied by dz is equal to 0. Now we will compare this value. When we will compare it, and you can notice that here we have x z cube is equal to 2bx z square. X cancels out with x and z cube with z square. So the value of b is z by 2. We will get value of b as z by 2. Is it clear? Now we also need the value of a here. We can notice that a is in this only. So we will simplify it. This will be a plus 2by. This is b, and then I will do one thing. I will put the value of 2 and b. It will be z by 2. X square z is equal to, this is 2y on this side, right? So we have obtained this value equal to this one, right? We will equate the coefficient of dz with this coefficient of dz. And I have put the value of b as z by 2. This will be a and this will be x square z square here. I will take this to the other side. So 2y minus x square z square will be value of a and this is the value of b. Now pay attention, we have u and v. Tell me what is the value of u? We can see that the value of u is z. Hence, we will substitute this value of u, and when you will see, you will find that the value of b in form of u is u divided by 2. Are you getting it? The value of u is z. And b is u by 2. So what did we do here? We substituted u in place of z. Therefore, we got b as u by 2. Clear? Students, look here at this 2y. v is x square y square minus 2y. And this is 2y minus x square. Sorry, z square. v is x square z square minus 2y. And it is 2y minus x square z square. So take minus common, this will become minus v. So whenever we calculate the value of a and b here, we will get like this. We started with this and now what we will do? The value of a is minus v and the value of b is u by 2. We'll put them here. This will become minus v. du, and what we will get as the value of b here? The value of b we are getting is u by 2 dv is equal to 0. Now what we'll do? We will separate it. Or else divide by uv, right? But I will separate this. Let's take it. So we will get, this is equal to u by 2 dv upon it will be du upon u and multiply to here. This will be equal to dv by v. Now we will integrate this and this will become 2 log u. This is equal to log of v plus log of, here I will take a constant a. I will take a, right? You can take any constant. Is it clear? This will go over there, so we will get log here. This will be u square. This will be equal to the log of v into a. So this will be u square is equal to v multiplied by a. This will be the answer. I hope you have understood it. Hence, the answer we obtained is u square is equal to v multiplied by a. Clear? Now we will substitute the value of u and a. The value of u that we have is z. So this will be z square. We will put the value of v here. This will be x square z square minus 2y into a. Hence, the solution of this total differential equation will be this. And now let me explain you again. We will apply this condition. Then we will get to values C1 and C2, which we will consider as u and v respectively. Then we will put the values of u and v in form of du and dv. We will compare this with this, which will give the values of a and b. Those values will be in form of u and v. We will put it here. Then we will integrate it, which will result in u and v. We will put the values in place of u and v, and we will get the answer. Next. Sometimes I might explain a lot of things. So you can also see the solution here. Let's look at the next question given here. How will you solve this question? First of all, you must remember the formula to solve it. Let me tell you that the value of p, it is given as 2x z minus yz. The value of q is 2yz minus zx, and the value of r here is minus x square minus xy plus y square. We get this value. Let me tell you that first of all you should know how to write the formula. Let's write it down as x, y and z. Then what comes next? Dx upon. What we get here, pay attention. Students, I will write it. We get del q here upon del z minus del r by del y, right? Is equal to dy upon what will we get? Do you remember this will be del r by del x minus del p divided by del z, right? This is equal to dz divided by, this will be del p upon del y. Is it clear? Minus del q by del x. This is our condition, right? Now look here, del x upon, we have to differentiate q with respect to z. On differentiating, we will get 2y minus x minus. We will differentiate r with respect to y. Let me differentiate r with respect to y. Del r by del y, we will get, if we differentiate y, then minus x will become plus x, and if we differentiate it, then 2y. We will substitute this value, so we will get minus x plus 2y. This will be the value. Similarly, we will discuss this dy. So differentiate r with respect to x on differentiating. We will get minus 2x plus y minus differentiation of p with respect to z. Then we will get minus 2x, and if we differentiate z with respect to this, so plus y. Similarly, dz, we will do p with respect to y. On differentiating p, we will get minus z. And if we differentiate q with respect to x, then this will give us plus z here, right? Because minus minus z will become plus z, right? Now we know that what is this value equal to? It is equal to lambda. It's becoming 0 in denominator. In that case, we will get dz equal to 0. Z equals c1, and we will consider this as u. We get this value. Now take the remaining two terms. So here we will get dx divided by, it is 4y minus 2x. Look here, what will be next? What will we get dy upon? Pay attention, what will be this? If you carefully notice here, we are getting this as 2y minus 4x. 2y minus 4x, is it clear? Now here we have 2 common which cancels out. Now cross multiply this. I'm going to first cancel it out, it will be better. So dx upon, in denominator we will get 2y minus x equals dy upon, students, this will become y minus 2x. Is that clear? Now we will cross multiply this and then we'll simplify it, right? When we cross multiply, then we will get y here minus 2x, and multiplied by dx is equal to, this will go to the other side and become minus term. So it will become minus 2y minus x dy equals to 0. Now check which terms are directly integrating. If it's with dx, then it is directly integrated. Plus y dx. Look at this, we have minus 2y dy plus x dy is equal to 0. The integration of these two is direct, and we'll write these two together. Therefore, I will write it as minus 2x dx. Minus 2y dy plus, we will write this together. So this will become dxy, right? Now integrate this, its value will be minus x square minus y square, as 2 and 2 will cancel out. Plus here xy. So this will become the value of v, right? So we got the values of u and v. Now what will we do? We will substitute the values of u and v. Let me erase it and then I will explain here. We know that what is the final answer we will get here. If you notice the answer which we get here, it is a du plus b dv equals 0. So what do? we are left with u, right? This is the value of u left here. So the value of du is equal to dz, right? And from here we can calculate the value of dv, right? Let's find it. If I calculate the value of dv, what will be the value of dv? So this value will be minus 2x dx minus 2y dy, right? Plus if we do this with u into v. So this will become x dy plus y dx. We will get the same value. Like the solution we did here, it will be the same. And now we will substitute this value here. So this value of du that we have and this value of dv, we will substitute these values here. When I will substitute it, then it will be a into the value of du is, that is dz, plus b multiplied by the value of dv. That will be minus 2x dx, and then it will be minus 2y dy and plus x dy. Plus y dx is equal to, it will be 0, right? Now what we will do? Let's write the coefficient of dx, dy, dz all together. It is dx. We are getting the coefficients of dx here. What is this? If you pay attention here, b is common here. And then here, this will be minus 2x and plus y multiplied by dx. Is it clear? Now let's discuss the coefficient of dy is here. We are getting b common, right? And we will get this as minus 2y plus, it will be x dy. Now write dz, and we will get its value as a dz, right? This will become equal to 0, right? Now, what are we going to do? We will compare these two values. This given differential equation and this expression here, when we will compare, then these two values will be equal, right? That means what we will get? B. Here we will get minus 2x plus y equals. It will be equal to this. Now let's take z as common. Then it will be 2xy in the bracket. Are you getting this? It will be equal to this. These two terms, the coefficient of dx and dx, so when we cancel it, if we take out minus common, then we will get value of b as minus z. Hence we are getting value of b as minus z. Is it clear? We will see later what are we getting in equal to this minus z. Let's leave it for now. Now let's talk about the value of a. What will we do to find a's value? We'll compare, right? We have this a here and this is its value, right? And now if we will check for the value of a, we will equate it with the coefficient of dz. This will be minus x square minus xy plus y square. So what we get this as? We get the value of a. Let's look at dv. What is the value of dv we are getting? Sorry, v. So now we will discuss. In this case, whatever values we got for a and b here, it will be in the form of v and u. So if you look here, the value of b, what will be this equal to? The value of u is z. And this is minus z, so the value we get will be minus u. Similarly, the value of a, what we will get? That will be in the form of v, because it will either be u or v. So here we have this as the value of v, right students? If we consider minus x square, if I multiply minus, so minus x square plus xy minus y square, then we got this as it is. For the value of v, right? We have got u and v, now we will put these values, right? Now I will put this value here and this here. Now the value of a that we get here, it is v, so write v dv. And this one will be minus u dv. It is equal to, it will become equal to 0. So this will be v du is equal to, separate u dv, du upon u is equal to dv upon v. We will integrate this plus log a, clear? Hence we will get the value. Its value will be log u, right? This will be equal to log v and plus log a, right? So now we will separate these values. Then we will get this value as log of u is equal to log av will come when we simplify this. So u is equal to, it will be av, right? Now put the values of u and v. So what is the value of u? The value of u that we have is z. We will write it here. And the value of v, the value of v is minus x square minus y square plus xy. Hence it will be the solution of this total differential equation. In this way we can easily solve it. I hope you have understood the method. Now this question is for comment box. How much time did you take to solve it? Let me know. If you want to watch older playlists of total differential equations and differential equations, then you can watch from here. Subscribe to channel. If you are looking to join any courses with us, then you can download our Mathscare app. The link is available in description. Thank you.